Today we are going to cover section 10.1, graph y equals ax squared plus c. The first section in chapter 10, quadratic equations and functions. Example 1, graph y equals ax squared where absolute value of a is greater than 1. So let's make a table of values to graph y equals 3x squared. We're using the plotting points method, which is really the only method you can use to graph quadratic equations. This is a quadratic equation because the highest power of the variable is 2. Let's pick convenient numbers to substitute in for x. The most convenient number to substitute in for x is usually 0. So that's going to be y equals 3 times 0 squared. According to PEMDAS, you do e for exponents before m for multiplication. 0 squared, 0 times 0 is 0, and 3 times 0 is 0. So when x is 0, y is 0. So that's the point 0 comma 0, which we'll plot on the graph in a little bit. The next most convenient number to substitute in for x is usually 1. So let's do that. Y equals 3 times 1 squared. 1 squared, 1 times 1 is 1. So that's 3 times 1, which is 3. That gives us the point 1 comma 3. Now let's substitute in 2 for x. Y equals 3 times 2 squared. Do e for exponents before m for multiplication according to PEMDAS. 2 squared is 4, 3 times 4 is 12. So that's 2 comma 12. And now let's substitute in a couple negative numbers for x. You should, for quadratic equations, it's good to have at least 5 numbers substituted in for x, at least 5 points. Substituting in -1 for x, that's y equals 3 times -1 squared. -1 times -1 is positive 1. 3 times 1 is 3. So we get the point -1 comma 3. And now substituting in -2 for x, y equals 3 times -2 squared. -2 times -2 is positive 4. 3 times 4 is 12. We get the point -2 comma 12. Now let's plot those 5 points. I'll copy it down up here because I'm going to have to erase the table to make room for the graph. So we have 0 comma 0, 1 comma 3, 2 comma 12, -1 comma 3, and -2 comma 12. Let's set up the graph. Notice that all the y values we got were positive because anytime you square a number, the result is always positive. So we don't have to deal with quadrants 3 and 4, which have negative values for y. We just need quadrants 1 and 2. And let's go up to 12 on the y-axis because that's the highest value of y in our 5 points. Okay, so 0 comma 0, 1 comma 3, 2 comma 12, -1 comma 3, and -2 comma 12. So it forms a parabola, a U shape when you graph it. Whenever you graph a quadratic equation. So there you go. there's the graph of y equals 3x squared. Let's compare that to the graph of y equals x squared. I'll use a different color marker for that. So y equals x squared. Let's use this maroon color marker. If you substitute in 0 for x, you get 0 for y. If you substitute in 1 for x, y equals 1 squared is 1, so that's the point 1 comma 1. And then 2 squared is 4, so the point 2 comma 4. 3 squared is 9. So when you substitute in 3 for x in the equation y equals x squared, you get 9 for y. The point 3 comma 9 is over here. And then substituting in -1 for x, -1 squared, -1 times -1 is +1. And then -2 for x, -2 squared, -2 times -2 is +4. And substituting in -3 for x in the equation y equals x squared, that's going to be -3 times -3 is +9, so the point -3 comma 9, right here. Connecting the points, it forms another parabola, but a wider one. So there is the graph of y equals x squared. Notice that there was vertical stretching that happened. The graph of y equals 3x squared rises more quickly than the graph of y equals x squared. So that's vertical stretching, which makes it look narrower. So if you multiply a function like x squared by a number with an absolute value bigger than 1, it's going to create vertical stretching, which makes it look narrower, and it rises more quickly. Now let's look at example 2. Graph y equals ax squared, where the absolute value of a is less than 1. And remember, absolute value means the positive version of the number. So the absolute value of -3, for example, is +3, or the absolute value of 5 is +5. All right, so this time let's graph y equals the quadratic function -1/4 x squared. And we're going to compare the graph with the graph of y equals x squared. Let's make a table of values to substitute in for x. Let's first substitute in the most convenient number for x, 0. That'll give us y equals -1/4 times 0 squared. 0 squared, 0 times 0 is 0, -1/4 times 0 is 0, which gives us the point 0, 0. Now substituting in 1 for x, we get y equals -1/4 times 1 squared. -1/4 times 1 is -1/4, which gives us the point 1, -1/4. And then substituting in 2 for x, y equals -1/4 times 2 squared. 2 squared is 4, which gives us -1/4 times 4. 4 on top cancels out with 4 on the bottom. So we get y equals -1, the point 2, -1. And now substituting in a couple negative numbers for x, like -1 and -2. We'll get y equals -1/4 times -1 squared. -1 times -1 is +1. Negative 1/4 times 1 is negative 4. So that gives us the point negative 1, comma, negative 1/4. And then finally substituting in negative 2 for x, y equals negative 1/4 times negative 2 squared. We'll get y equals negative 1/4 times 4. 4 on top cancels out with 4 on the bottom. We get y equals negative 1, so the point negative 2, comma, negative 1. Now I'm going to copy the points up here because I'll have to erase the table to make room for the graph. So we have 0, comma, 0. So the point 0, comma, 0 is right here. Y equals negative 1/4 x squared. The point 1, comma, negative 1/4 is over here. 2, comma, negative 1 right there. Negative 1, comma, negative 1/4 right here. And negative 2, comma, negative 1 right here. So it's an upside down parabola this time, an upside down U shape. So anytime you multiply a function by a negative number, it gets reflected on the x-axis. So it gets flipped upside down, in other words. And let's compare that to the graph of y equals x squared. I'll use this purple marker to represent the graph of y equals x squared. So substituting in 1 for x, you get 1 for y, 2 for x. That's going to be 4 for y, which is off the graph. Substituting in negative 1 for x, that's 1 for y. And negative 2 for x, that would be 4 for y in the graph of y equals x squared. Negative 2 comma 4, that's way off the graph. Okay, so the purple there is the graph of y equals x squared. So if you multiply a function by a number with an absolute value less than 1, it causes vertical shrinking. So the graph rises more slowly and it's going to look wider. So comparing the graph of y equals x squared and the graph of y equals negative 1/4 x squared, notice that the graph of y equals negative 1/4 x squared looks wider. So vertical shrinking took place because x squared was multiplied by a number with an absolute value less than 1, like negative 1/4. Now let's look at example 3. Graph y equals x squared plus c. Y equals x squared plus 5. So our c is positive 5. And we'll compare the graph with the graph of y equals x squared. Let's make a table of values. Substituting in 0 for x, that's y equals 0 squared plus 5, which is going to be y equals 5, which gives us the point 0, comma 5. Substituting in 1 for x, That's y equals 1 squared plus 5, which is y equals 6, which gives us the point 1 comma 6. Substituting in 2 for x, we'll get y equals 2 squared plus 5, which is y equals 9, which gives us the point 2 comma 9. Now substituting in a couple negative numbers for x, such as -1 and -2, we'll get y equals -1 squared plus 5. -1 times -1 is +1. 1 plus 5 is 6, which gives us the point 1 comma 6. And then substituting in -2 for x, -2 times -2 is +4. 4 plus 5 is 9. So we get the point -2 comma 9. And I'm going to copy these points up here because I'll have to erase the table to make room for the graph. So 0 comma 5, 1 comma 6, 2 comma 9, 1 comma 6, oh sorry, -1 comma 6, and -2 comma 9. We're going to need to go all the way up to 9 on the y-axis. 1, 2, 3, 4, 5, 6, 7, 8, 9. We only need to, I'm just going to put 3 tick marks on each side for the x-axis. Two, 4, 6, 8 on the y-axis. Okay, so 0 comma 5 is right here. 1 comma 6 right there. 2 comma 9 up here. -1 comma 6 is over here. -2 comma 9 is over here. Connect the points, it forms a parabola. It's not upside down this time because the function x squared is not being multiplied by a negative number, so it's not reflected on the x-axis. And let's compare that to the graph of y equals x squared, which I'll put in maroon here. So, which has the points 1 comma 1, 2 comma 4, 3 comma 9, -1 comma 1, -2 comma 4, -3 comma 9, oh, 0 comma 0. Okay, so it looks, the graph of y equals x squared plus 5 looks the same as the graph of y equals x squared, except the graph of y equals x squared plus 5 is shifted up 5 units. So anytime you add a positive number to a function, it's going to be a vertical translation upwards. So the graph gets shifted up. If you add a negative number to a function, it's a vertical translation downwards, so the graph gets shifted down. All right, so that's what you do in a situation like that. And then let's graph example 4, y equals ax squared plus c. We'll graph y equals 1/2 x squared minus 4, and we'll compare the graph with the graph of y equals x squared. Y equals 1/2 x squared minus 4. We'll make a table of values. We'll go back to the blue marker. Substituting in 0 for x. we'll get y equals 1/2 times 0 squared minus 4. Remember to follow PEMDAS, E for exponents before M for multiplication before S for subtraction. 1/2 times 0 is 0. 0 minus 4 is negative 4. That gives us the point 0, comma, negative 4. When x is 0, y is negative 4. Then substituting in 1 for x, y equals 1/2 times 1 squared minus 4. That's going to be y equals 1/2 minus 4. Okay, so that is going to give us, well, negative 4 is the same thing as negative 8 over 2, because 8 divided by 2 is 4. Now we have a common denominator, which we need because we're subtracting. 1/2 minus 8/2 is negative 7/2. And negative 7/2 is negative 3.5, because 7 divided by 2 is 3, remainder 1. So now we have the point 1 comma negative 3.5. Substituting in 2 for x, that'll give us y equals 1/2 2 squared minus 4. Two squared is 4, so 1/2 times 4 minus 4. 1/2 of 4 is 2, and 2 minus 4 is negative 2. That gives us the point 2 comma negative 2. Substituting in negative 1 for x, we'll get y equals 1/2 times negative 1 squared minus 4. Negative 1 times negative 1 is positive 1. 1/2 times 1 is 1/2. 1/2 minus 4, as we saw earlier, is negative 3.5. So we get the point negative 1 comma negative 3.5. And then finally substituting in negative 2 for x, we get y equals 1/2 times negative 2 squared minus 4, which is y negative 2 times negative 2 is positive 4. Y equals 1/2 times 4 minus 4, which we saw earlier in the table when we substituted in positive 2 for x, is negative 2. So that's the point negative 2 comma negative 2. And I'll copy those points up here, since I'll have to erase the table to make room for the graph. 0 comma negative 4, 1 comma negative 3.5, 2 comma negative 2, negative 1 comma negative 3.5, and negative 2 comma negative 2. So 0 comma negative 4 is right here. 1 comma negative 3.5 is right here. 2 comma negative 2 right here. Negative 1 comma negative 3.5 right there. Negative 2 comma negative 2 right here. And there we go. So it forms a parabola, not upside down because x squared was multiplied by a positive number. Now let's compare that to the graph of y equals x squared, which has the points 0 comma 0, 1 comma 1, 2 comma 4, negative 1 comma 1, negative 2 comma 4, notice that the graph of y equals x squared and the graph of y equals 1/2 x squared minus 4, so the graph of y equals 1/2 x squared minus 4 is shifted down 4 units from the graph of y equals x squared because a negative number was being added, or in other words, a positive number was being subtracted, so it got shifted down 4 units, a vertical translation downwards. And also because the function x squared was being multiplied by a number with an absolute value less than 1, like 1/2, vertical shrinking happened. So the graph of y equals 1/2 x squared minus 4 does not rise as quickly. It rises more slowly, so it looks wider. Now let's look at example 5, standardized test practice. How would the graph of the function y equals x squared plus 6 be affected if the function were changed to y equals x squared plus 2? How would the graph of the function y equals x squared plus 6 be affected if the function were changed to y equals x squared plus 2? The graph of y equals x squared plus 6 is the same as the graph of y equals x squared, except that it's shifted up 6 units because positive 6 is being added to the function y equals x squared. And the graph of y equals x squared plus 2 is the same as the graph of y equals x squared, except it's shifted up 2 units because positive 2 is being added. So if you're comparing the graph of y equals x squared plus 6 and the graph of y equals x squared plus 2, altogether the graph of y equals x squared plus 2 is the same as the graph of y equals x squared plus 6, except shifted down 4 units. Since 6 minus 2 is 4. The graph of y equals x squared plus 6 is shifted down 4 units to obtain the graph of y equals x squared plus 2. And now one last example problem. Example 6, use a graph. It's a word problem. A solar trough has a reflective parabolic surface that is used to collect solar energy. The sun's rays are reflected from the surface toward a pipe that carries water. The heated water produces steam that is used to produce electricity. The graph of the function y equals 0.09x squared models the cross-section of the reflective surface where x and y are measured in meters. Use the graph to find the domain and range of the function in this situation. All right, so we have the quadratic equation y equals 0.09x squared. So the domain is x is less than or equal to positive 5 and greater than or equal to negative 5. So we can only substitute in numbers between negative 5 and 5 for x. Because the reflective surface extends 5 meters on either side of the origin. On either side of the lowest point of the parabolic reflective surface of the trough. Okay, so let's substitute in, to figure out the range, let's substitute in -5 for x and +5 for x. So y equals 0.09 times -5 squared. -5 times -5 is +25. 25 times 0.09. 9 times 5 is 45, carry the 4. 9 times 2 is 18, plus 4 is 22. Two decimal places in the multiplication problem, so we need 2 decimal places in the answer. And then now let's substitute in +5 for x. That's y equals 0.09 times 5 squared, which is 25. Y equals 0.09 times 25, we already figured out, is 2.25. And if you substitute in 0 for x, I already mentioned that that would be the lowest point in the trough in the reflective parabolic surface, which looks like this. It's a pretty wide parabola because 0.09 has an absolute value pretty close to 0. So yeah, the lowest point is when you substitute in 0 for x. So that's y equals 0.09 times 0 squared. 0 times 0 is 0. So we get 0.09 times 0, which is 0. So that's the point 0, 0. Here is the point -5, 2.25. Meters. -5 meters just means 5 meters to the left of the lowest point in the parabolic reflective surface. And then this point here is the point 5, 2.25. So +5 meters means 5 meters to the right of the lowest point, or of the center of the surface. So the range is all the possible y values. So the range is y. The range is y is less than or equal to 2.25 meters and greater than or equal to 0. So the height of the reflective surface ranges between 0 and 2.25 meters. And that thus concludes section 10.1, graph y equals ax squared plus c. Thank you.